Hello everybody. In this lecture, I'm going to show you how to calculate the moment of inertia of a cone. First, I would like to start it with a hollow cone. Hollow means inside is empty. So this is the cone. Okay, so this is the base. So from this center, I'm considering it will look like a circle only. Base will look like a circle only. Its radius I'm taking as capital R, and height from the vertex to this base, this I'm taking as capital H, and its mass capital M. So the cone under the consideration here is a hollow cone. So to find the moment of inertia with respect to an axis, what is that axis? This is called axis of the cone axis only, this axis. Okay, with respect to this axis, I wanted to find out what is the moment of inertia of the system. For that purpose, from this vertex at a distance, let me call it as y, I'm considering a small element. How does this element look like? This element will look like a circle only. And thickness, let me call it as dy. Its thickness I am calling it as dy. And its mass I am treating it as dm. So due to this small element, what is the moment of inertia with respect to this axis? That is nothing but di is equal to mass of the strip dm into its shape is circle. When it is rotated like this circle is rotating about this axis. Am I right? Because of which moment of inertia is dm into r square only, where small r is the radius of this strip. To find what is the radius in terms of r and h, okay, let us take two similar triangles. Let me call it as O, let me call it as A, B, C. There are two similar triangles, C, O, B, A, O, let me call this as D, AOD. So from the properties of similar triangles, what I can write? R divided by small r, capital R divided by small r is equal to, what is this total height? Capital H divided by, okay, what is this height? Y. All this I did purely to calculate what is the radius of this circular board. I wanted to calculate what is dm. To calculate dm, here I am defining sigma. What is the sigma? dm divided by dA, which is nothing but m divided by a. Through this, dm is equal to what I can write? Sigma dA. What is the area of this strip? So dA is equal to area. Area is how much? Perimeter. What is its perimeter? 2 pi small r into thickness. How much I considered it as? dy. 2 pi small r into dy is the thickness. So through this, dm is equal to how much you're gonna get? dm is equal to sigma 2 pi into r dy. So if we go back to this, therefore di is equal to, after substituting all these things, we're going to get di is equal to, dm is how much you got? Sigma 2 pi. Okay, here integration is with respect to y. I want to eliminate r. For that I am using this expression. Through this expression, r is equal to what you're going to get? R is equal to y into capital R divided by capital H. That I am substituting here directly. So here there is one r square, here there is another r. R square into r is how much? R cube, where r is y into capital R by H whole cube into dy. Therefore, total moment of inertia is given by capital I is equal to sigma and 2 pi capital R H, all these are constant. So sigma 2 pi into R cube divided by H cube into what you can write? Y cube dy, summation over y cube dy. What are the limit of integration for y? The value of y, when you start it at algorithm, y is equal to 0. By the time you reach this, y is equal to h, 0 to h. That is equal to sigma 2 pi r cube divided by h cube into integration of y cube, y power 4 divided by 4 between the limits 0 to h. That is equal to sigma 2 pi into capital R cube divided by h cube into this you can write as h power 4 divided by 4. That is equal to what is sigma? Mass per area. Mass is capital M divided by area of hollow cone is how much? 2 pi capital R, pi into capital R into its length. Let me take it as h only. Pi capital R into capital H into, okay. So this is how much? H cube, h power 4 gets cancelled. You will be getting R cube into H divided by 4. Through this, how much you're gonna get here? Pi. Here there is 1, 2 pi is over there. No, you write it as it is. Pi gets cancelled. 2 1s are 2 2s are, and R cube R gets cancelled. H also gets cancelled. You will be getting M capital R square divided by 2. So with respect to this axis, which is passing through its center of mass also, so that axis, let me call it as I. Let me call it as O. I O C is equal to mr square divided by 2. I'm going to calculate a moment of inertia of solid cone. This is hollow cone. No? Now I wanted to calculate for a solid cone. So to calculate for a solid cone, I should imagine a cone like this. This is the cone. Let me call this is the base of circle of radius. Radius of this base is how much? Capital R I'm taking. Height from this vertex to base, this height is capital H and its mass capital M I am considering it as. Okay, so I am considering moment of inertia with respect to an axis, which is cone, axis of the cone it is called. Okay, so let me call this point as O, let me call this point as A, and this point as B. So I wanted to calculate IOA. So for this purpose, what I will do is, I will consider from this point O at a distance y, I will consider a small strip. Small strip. The strip will be in which form? It will be in circular form because it is a cone. And this thickness I am treating it as dy. First I will find out moment of inertia of this small strip. Let me assume its mass is dm. Okay, therefore di is equal to, it is in disk form. So what is the moment of inertia of disk? Mr square divided by 2. Here m is how much? Dm. Let me call its radius is small r into small r square divided by 2. So now the problem is to calculate dm. What is dm here? Rho dv. Here rho dA because it is hollow, but here it is a solid because of which it is rho dv. That is equal to rho into what is dv? Volume of this element. How much it is? Its area pi r square into its thickness how much? dy. So dm is equal to pi r square dy. Through this di is equal to what I can write? dm. dm is how much? Rho pi r square dy into r square divided by 2. Now this r is something which I assumed, it is not there in the problem, so I should write down this r in capital, in terms of capital R and capital H by using properties of similar triangle. That is this relation. I am using it here directly. That is equal to what I can write? R square into r square r power 4 sigma pi divided by 2 into r square into r square r power 4, where r is y into capital R divided by capital H all power 4 into dy. Okay, so to calculate total moment of inertia IOA, What should I do? Simply I should integrate. In this integration, sigma, pi, 2, r, h, all are constant. That's why I'm pulling them outside the integration. Rho into pi into, okay, r power 4 divided by, this is how much? 2 into h power 4 into summation over 0 to h. This is how much? Y power 4 divided y power 4 dy. That is equals, what I can write? Sigma, what is sigma? Volume of the cone, density of the cone. Mass divided by volume. Volume of the cone is how much? 1/3 pi r square into capital H. This is volume of the cone. So rho I wrote it. Remaining parameters pi r power 4 divided by 2h power 4 into y power 4 integration y power 5 by 5. If you substitute h, it will become h power 5 divided by 5. Okay, in this, let us cancel whatever the things that are going to cancel out here. So pi r power 4, pi r square gets cancelled, 1 r square remaining, however. H power 4 into h power 5, h power 5 completely cancels out. 2 5 is 10, this 3 goes to numerator. So 3 divided by 10 into m into r square. This is the expression for moment of inertia of solid cone with respect to its axis, that is IOA. So calculating the moment of inertia with respect to the axis for solid cone as well as hollow cone is very much similar only. Only thing is here we will consider area, here we consider volume. That is the only difference. Thank you.